All right, so we want to talk about the gamma function, but we're going to do something special today. We're going to view it in a way, at least it's novel to me, and it isn't what you run into if your search of the gamma function is included, say, Wolfram Alpha or Wikipedia, and no other visual generator. So we're going to be viewing the phase diagram, or the phase plot of the gamma function from giant scale and zoom all the way in. And you're going to see some fantastic structure. Before we do, I want to review some of the interesting features and facts that we know about the gamma function. First of all, in general, what is the gamma function?
It partitions things.
It's the analytically continued version of?
From the zeta.
From the?
Oh, the factorial.
The factorial function. Okay, so the factorial function is defined for n's that are whole numbers, right? N equals 1, 2, 3, 4. And so really, if you were to draw it as a function, its output, it gives you answers that are on the real number line, right? But nothing between. It's just dot, 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 okay, for the answers.
The gamma function is formed along with factorial.
So the gamma function is a way to analytically continue that structure through the whole plane.
You could think of it, it's also like a measure of growth and or decay, depending on, because it always usually shows something that is growing or decaying.
Yeah, okay. It's totally directly related. All right, the gamma function is also directly related to a very famous thing in the zeta in mathematics, the zeta function, right? It's the same conversation. In fact, the zeta function is kind of a double copy of the gamma function, by which I mean, let's see, which one should we start with? So the gamma function, if I say of s, here I mean s equals x plus iy, just a two-dimensional number, okay, shorthand for it. Then I can write it in terms of an integral, really forget it, let's do this on the wrong side, 0 to infinity, x to the s minus 1 over e to the x dx. Okay, and the super famous zeta function can also be written in terms of the gamma function. 1 over gamma s times by integral 0 to infinity x to the s minus 1 over e to the x minus 1. Other than this minus 1, this would be that. This would be 1 over the gamma function times by the gamma function, which equals 1. Okay? The whole thing would just be 1 if this 1 wasn't there. All right, so really it's kind of a double copy of the gamma function with an offset. Okay? All right, but the zeta function, of course, is the one whose zeros are directly related to all the primes, right? There's a lot of central questions that people famously know about the zeta function. Okay, so we want to focus more on the gamma functions, like maybe a simpler version to start with, right? Okay, so what are some cool features we know so far about the gamma function? Anybody remember any of them?
Well, gamma 5 is 24.
Yes. Remembers one specific one, gamma of 5 equals 24. Okay. What about
Gamma 1 over 5 is peak algorithmic incompressible.
1 over negative 1?
I don't know.
0. In fact, 1 over gamma of negative n equals 0.
Anything negative?
Yeah, well, n is 0, 1, 2, 3, 4, 5, 6. So, very specifically just those. Well, all the way up. But the zeta function, by the way, has an interesting corollary. Starting with n equals 1, not at 0. So, offset in the start. But look at the interesting negative n, negative 2n. This one's inverted. Okay, and that's defined in all of its trivial zeros, all the ones that go off to the left, right? That are trivial because it's easy to expect or talk about the pattern that captures all of them. Okay, so here's another one. Let's see, gamma of, not zeta, gamma. I could have done some zeta, but we don't need to. Gamma of 1/2, negative 1/2. They're kind of interesting. Remember this one? Square root of pi. Okay, that seems kind of interesting. Now we're interpreting the gamma function, by the way, to be more explicit, as a hyperbolically a divisor function, right, of hyperbolic division. So the gamma function is, for us, interpreting the connectivity in the number line or in the field as a hyperbolic construction. So it's central for us in describing how the construction in numbers exists to begin with. At least that's where we're going. So this square root of pi is extremely interesting. Let's just change this to gamma of negative 1/2. What would you expect that's going to change?
Is it going to be pi?
Negative square root of 4 pi.
Oh.
So if you multiply them together, you get negative 2 pi.
So, let me see. So,
Oh.